Good everyone. Uh, in this video I will be talking about first principle, but I will use first principle to differentiate trig functions like y equals to sine x. Amen. Okay, I'm going to show you how to differentiate, how to use first principle to differentiate sine x, as simple as ABC. It's okay. Let us have example, differentiate y equals to sine x from first principle. If y equals to this, differentiate y equals to sine x from first principle. Amen. Okay, as simple as ABC. Okay, let's write solution. Our y is equals to sine x. Don't be surprised. Sometimes they may say the independent variable here is x, but sometimes they may say instead of x, they may say theta is the same thing. Sometimes it will be t. Sometimes it will be what? P. It's the same way you are going to approach it. Is that clear? Just that the independent variable will change. Not necessarily you will see x. Is that clear? Okay. So now let us differentiate this idiot. In our first video, I tried to demonstrate how to use first principle to differentiate function. Let us write out the formula. Y plus dy is equals to what? F of x plus dx. Two of us. Amen. So it implies that our y is equals to sine x, isn't it? So now if we put the bracket, our sine is this f, two of us, then our x is this x plus dx. This is how you are going to apply it. So if you can see what I am saying, let's go. Okay, so our y plus dy is equals to, I told you, our f is what? Sine. Then our x is what? Our x plus dx. Amen. Okay, so now our dy is equals to, if we subtract y from both sides, we have sine x plus dx minus y. Amen. Then our dy is going to give us sine, open bracket, x plus dx minus, what is your y? Is sine x. Sine x. Please, you are not going to write sine x here. Is that clear? We try to compare this and this. Okay? So here will be sine. Then your x is this x plus what? Dx. Take note. Okay? So now, let us go back. You don't need a prophet to tell you. If we have sine, open bracket, x plus dx, go back to your elementary trig. Amen? Your elementary trig will tell you that, go back to your elementary trig. If we have sine theta 1 plus theta 2, this is how it is. True of us. This is how it is. So it means your theta 1 is x, your theta 2 is dx. So, but now let me just write it out for you. If we have this, we don't need a prophet to tell you. This is what? Sine theta 1 cos theta 2 plus cos theta 1 and sine theta 2. True of us. Yes. So it means since we are using x, we have x plus dx here. We are not going to use theta, but this will be, we now say, note that our sine in bracket x plus the x is equals to sine x cos the x plus cos x sine dx. Amen? Okay, so this implies that instead of sine open bracket x plus dx, we are going to write this one. So our dy is going to be sine x cos dx plus cos x sine dx, then minus sine x, amen? Minus sine x. True or false? Okay. So if we take collect like terms, we have sine x cos dx and we have sine x. They are like terms. So either we bring it this way or whichever way we want to do it. So if we take it that way, it means our dy is equals to cos x sine dx, amen, minus sine x plus sine x cos dx. Okay, so now if you can see what I am saying, our dy is equals to cos x sine dx. What is common here? Minus sine x, isn't it? Minus sine x, all in bracket 1 minus what? Cos dx, isn't it? True or false? It's true. Because if you use this sine x to multiply 1, you still get back minus sine x. Then if you use this sine x minus sine x to multiply minus cos x, you will have that is plus sine x cos what? Dx. True or false? Okay? So if you agree with me, at this point, we are going to divide through by the x. Right, divide through, amen, divide through by dx, amen. Okay, so if you agree with me, amen, here will now be dy all over dx equals to cos x sine dx all over dx, then minus sine open bracket 1 minus cos dx all over dx. Amen? Okay? Okay? Do you agree with me? Yes, this is how it will be. Now, we now introduce limits. As limit dx tends to 0, amen, our dy all over dx is equals to cos x sine dx all over dx. The whole of as limit dx tends to 0, all of this will be 0. Is that clear? Then we'll be left with this. So then sine x dx is what? 1. But ordinarily, if we are to differentiate this function, our dy all over dx, we're going to give us cos x. True or false? Yes, that is the answer. So now, as limit, we introduce limit here will be 0. Then sine dx all over dx is 1. So therefore, our dy all over dx is equals to cos x. This is what we are going to arrive at. This is our final answer. Is it difficult? Any question? No question? Thank you and God bless you.